Okay, on to movement now, and there's a range of ways to do this. We're going to start quite simple, where our enemy will just bounce between 2 points. So basically set an end point and have the enemy automatically move from where it started to that end point and back, and just keep repeating that process. So this is going to take a new script. So in script here, I'm going to create a C# script, and I'm going to call this simple enemy movement. Really doesn't matter what you name it as long as it makes sense to you. But let's fire that up. And we're at the point where we need to think about a few things again. So much like we did with the player's code, we'll keep these two because they're actually quite useful. Think, what do we need to know? And then what do we need to do? So in terms of needing to know, we need to know where we're going to move towards, don't we? So we'll need an endpoint. It's just the code trying to preempt me. So we need an endpoint. If we're going to bounce between the start and the end, we're going to need to know the start point. And we're going to need a movement speed, much like we did with the player. So there's 3 things we're going to need to know that we can store. In terms of what we need to do, start and update are actually quite useful because at the start we can remember where we started. Update, obviously we're going to move every frame, so that's quite handy. But in terms of the actions of this player, we need it to move towards the point, don't we? So we need it to move towards a point. And we need to see if it's arrived. It are. So there, the bits we're going to turn into variables. These are going to be our extra functions, and then we can use them from inside the update, really, can't we? So in terms of endpoint, start point, speed, let's just reformat them into usable bits. Our endpoint is going to need to be set from outside, so let's make this a public vector3. I know we're making a 2D game, but just in interest of keeping it consistent with the way that objects are positioned in Unity, we'll use a 3D vector. So even though you're making a 2D game in Unity, objects still have an X, Y, and a Z position. So just to match up with that, I'm going to follow suit, and I'm going to call it endpoint, written in camel case. The start point's slightly different in that we don't need to set it outside. We're just going to put the object where we want it to start and then automatically remember that in our start function down here. So this can actually be private, or you can just totally omit it. We can just go vector3 start point. But if it helps you make the notice the difference between them, we can put private there. So we know that that's public, this one's private. Don't know why it's still red, but oh well. And then finally the speed. Let's make this a public float called move speed. We can set a default there, set it to 3 units per second as a default. That's really bothering me that it's red, but it'll change. Okay, and then 2 functions. So let's just start with the first one. Void move towards, I'm going to call it target. Move towards target. Done. And then see if it's arrived. Let's call that, oops, void, let's call it check arrival. That's where we can react to arriving at where we're trying to be. And we're pretty much set up there. So we've got the point we want to move towards, the point we started, and the speed we want to move at. Here we've got the function that we're going to put the logic for actually moving between those points. And here we're going to check to see when we've got to one or the other. Okay. In the start function, I'm going to have it remember the start point. So this is private. This actually needs to be dealt with in code. So here in the start function, I'm going to say start point equals transform.position. Nope. So the starting point for this movement is where the object is placed in the Unity scene. So that one's easy. We can tick that one off. I'm actually going to shrink it down. Then we have these two functions that need to be used. So this update function is actually going to make use of these two. So every frame we're going to move towards the target. That's a function call, so it has the brackets, and because there are no parameters we don't have to put any extra information in those brackets. And then we want to check the arrival. And again, no extra information needed, so we just have the brackets. So that's the update function. And just in the interest of keeping the screen a bit less cluttered, I'm going to delete what I can, and I've collapsed the functions. So the code's still there, but it's just dropped down. Which means we can focus on these two. So the move towards target, I suppose, is the most important one. We will have some movement even if we just always move towards the end point. And it's actually fairly straightforward. You could play around with all sorts of vector maths here. You could use things like trigonometry if you wanted to move towards a point. But we're actually going to use one of Unity's built-in functions. So we're going to do transform.position equals. And then we've got in the vector3 class, we can do a dot and we can dig through what's possible, but we've got a move towards function. So I'm going to move our position vector towards a target vector. And we put those in brackets. So in a bracket here, we want to follow the rules that it's passing us. So our current position is just transform.position again. Then a comma to separate out these bits of information. The target, the place we want to be, is this endpoint. So we're going to put endpoint there. And then the float max distance delta is how far we want to move in this particular instance. And that's actually our move speed multiplied by the delta time from within Unity, so that it moves us per second rather than per frame. So here we're going to do move speed multiplied by time dot delta time. Hopefully it fits on the screen. I've put the wrong delta time. Just about gets on there, doesn't it? I can always shrink the code, but there's the full line. So move towards is the function in the vector3 class that we're using, and the information it needs is your current position, the position you want to be, and how fast you want to move, or how far you want to move towards it. And they all combine to move the object towards the end point. So I'm actually going to save it at this point, go back to Unity, click on my enemy there, and drag the script on. So I've got an endpoint of 0, 0, 0. So our enemy here is going to try to move to the origin of the screen, which is right in the middle. So if I hit play, there we go. Moves towards the middle and then it stops because we've not actually done anything when it arrives there. Which is what this check arrival function's for. And that's actually the trickiest bit of the code. Let's stretch this out. There we go. Much better. So in the check arrival function, this is where we do the thinking. So we want to know if we've arrived, and there's various ways to do it. We could ask, just to avoid any little rounding errors that might happen with the positional information, we can ask if the distance to the target is below a certain threshold, or we can just ask if it directly equals the position. So we can ask if our transform.position matches the position of the endpoint. So that would be if, and then in brackets we'd ask if transform.position equals 2 equals when you're asking a question, endpoint. So if our current position directly matches the endpoint, then we respond. And our response is actually flip the 2. So we want to put the start point into the endpoint and the endpoint into the start point. So you might think, oh, I'll just do endpoint equals start point, and start point equals endpoint. But problem with that logic is when you get to the second line, endpoint already equals the start point. So you actually set start point back to be itself, and endpoint then forevermore matches the start point. So we actually need a little a temporary variable to hold one of them while we swap the other one around. So just up here, in fact, let's just reorder it. So up here I'm going to make a new vector3, just a temporary one that will only exist inside this if, and I'm going to call it new target. And that's going to be our start point. So the new end point is eventually going to be our start point, but just before we can set it, we need to make the start point match the end point, which we've got there, and then finally we can make the end point match our new target. There's quite a bit of stuff going on there. Let's just review it again. So if our position exactly matches the end point, we're going to store our start point in a temporary variable, make the start point equal the end point, and make the end point equal that new target, the temporary variable that we stored our start point in, our original starting point. Bit of logic to wrap your head around, but basically those three lines just flip the start and the end point around. Let's save it and see how it goes. So back in Unity, hit play. And you can see that it just ping-pongs between the two, which is great. Just going to watch it for a bit. I did mention a slight issue with potential rounding errors. So asking if two vectors are directly equal, it can be quite tricky with the way particularly this function works. If this function is moving us towards the end point, it will do certain bits of maths that could lead to these two not entirely matching. There might be 0.00000001 difference, for example. So you can actually just defend against that. It's very rare that it will happen, if it ever does. But we could put vector3 dot distance. So this distance function will give us the distance between 2 points, and the 2 points we're interested in are our transform.position and our end point. So we can ask the distance between these 2 points. That actually uses Pythagoras behind the scenes. So if you're up on your Pythagoras maths, that is how you can figure out the distance between two vectors. We basically make an imaginary triangle between them and do the a squared plus b squared equals c squared thing. After we've got the distance, we want to know if it's less than, and you can just ask a certain amount. So if it's less than 0.1, for example, that means we're close enough to the target without having to exactly match it. Then we can flip them. And I'm going to leave it like that, but feel free to use the slightly less wordy version if you like. So that's saved. Let's give it a go. And it will bounce between the two. Okay, so what we can actually do is set this endpoint through the inspector. So that's why we made the endpoint public. It's just a little awkward because we've got no visual, so we will actually add in a little handy function. But we could look at where we are. So we could start from here. The y is -3. I'm going to round it off a bit. And the endpoint, well, we start at sort of 0, and we want to go left a bit, so maybe around here is -2, -3. We're doing a lot of guesswork. There you go. So -2 wasn't enough, but it's working, but it's a bit awkward. So we can actually make use of something in code to just give us a visual indicator to show the line, the path that we're going to follow. So if you want to use that, just going to add it in at the bottom, and it uses one of Unity's messages again, which is void on draw gizmos selected. So when this object is selected, Unity will draw the gizmos like the movement tool, rotation tool, and so on, but we can add our own in. So on draw gizmos selected, when this object is selected, we want to draw something else. So I'm going to start by setting a color. So we can do gizmos.color using American spelling, and what would make sense in mine. So a bit of contrast I want. White is probably too bright, maybe just go black. So color.black. So we're going to draw our lines in black, and then we want to just actually draw them in. So gizmos dot, we want to draw, let's start by drawing a wire sphere. So I'm going to draw a wire sphere at the end point. So that's a function, so in brackets it wants to know the center of that sphere, that's going to be endpoint. And the radius, let's just go 0.5f. So the entire y-sphere is 1 unit wide, placed at the endpoint. And then underneath that, let's do gizmos.drawLine this time. And the line's going to go from start point, or sorry, from where we are, so from transform.position to the end point. We don't actually set the start point until the game's running, so using start point there would have been wrong. But if I save that, go back to Unity, give it a second to compile, with the object selected, you see that we now have this little preview of the line, and we can now drag it around to make it that bit easier. Thicker lines would be nice, but feel free to play around with figuring that out. There will be some documentation out there for you. And that's it. It's now dead easy to see where this object's going to go. I could have it move all the way over there. I can hit play and it will definitely do that. Woohoo! Okay, so there's your simple enemy movement. We're going to press on in the next video to have waypoints that make it a bit more complicated.